Welcome to Natural Habitat Adventures Daily Dose of Nature. Today's topic, Nature's Decoders, Following Animal Footsteps, presented by NatHab Expedition Leader Nikki Sentinella. I'm your host, Rob Mess. Thank you so much for being here with us today. Take it away, Nikki.
Thanks, Rob. Good morning, everyone. Good evening, good day, wherever you're from. Welcome to another installment of Nature's Decoders, where we just kind of look at some of the signs of the natural environment, regardless of where you are in the world. Now, currently, I'm here in Australia on a Wabical country, so I will have a few more examples of Australian things because that's what I've taken photos of. But we're going to talk about some things a little bit more generally on how we can look at some tracks that we can see here and follow in those animal footsteps, what we can learn, and the research that has happened through that. So, hello, my name's Nikki. I am Australian. If you haven't picked that up already, I am very fortunate to be an expedition leader with Natural Habitat Adventures, and I've guided all across Australia as well as in Canada, up in our polar bear program up at Churchill. I am also a biologist when I am not out guiding. I'm in the field or I am behind a computer analyzing that field data. And I am a photographer as well. So there's definitely been a lot of times that I've been staring at the ground and having a look at these tracks. So I'm going to take you through that today. So today we're going to have a look at just some examples. I won't be able to cover every species in the world. I wish. So I'm going to be looking at some ideal tracks, have a look at what we can be looking for, and we're going to have a little look at the media of tracks, and we're not talking about their social media feed, but what is the medium that those tracks are in? Is it in sand? Is it in snow? What are the differences and how does that change the way that we interpret those tracks? What are the sort of tips and tricks to look for in that regard? And we're going to start to learn the language of tracks. What are we learning? We're actually not just learning who has been walking there, but we can learn a lot of other information. We can learn, things about the behavior as well as hopefully what kind of species. And if we start looking at the research applications, we can even get a lot more information, like some DNA that we can pull from tracks. So we'll talk about that. And mention briefly some ways that you can get involved in tracking. The best way to learn how to interpret tracks and to do so more reliably is to just practice. As with anything, practice is how that's going to happen. So some little ways that you can do that, even in your backyard. And as Rob mentioned at the end, we do have time for questions as well. So if you have any questions, feel free to submit them during the whole webinar and then we'll have a look at the end. So that's what we're looking at today. So let's dive in. So tracks are maybe some of the things that we consider are maybe like hiking tracks. This is obviously the lovely Grand Canyon. And you can see this walking track that extends, squiggles down from the bottom of the screen and continues all the way along that small little rivulet. And so tracks, once they're really established, can be really quite prominent. And it's something that we as humans leave marks all across the landscape, but a lot of our other animals are leaving those marks as well. We can see this in the form of game trails, but if we start to look at more subtle cues, we can actually see those signs of life anywhere we go, really. We're obviously known for leaving our mark. I mean, this is a classic. I was very excited to go to Canada and do my first snow angel. You could call this a form of track. This is, an indicator of which species was there. I can also tell some of the behavior, like me laying on the ground and being silly. And you can also tell how fresh it is. It's nice and powdery, it's quite crisp. You can tell that this is probably right after I did it. So we can learn a lot from the marks that we make. We even use tracks to communicate to each other. This is our lovely guide, Scott, down in Great Ocean Road. in southern Australia, and he's drawing a mud map for us to get a little bit of a view of what's around us. And I often draw in the sand as well to show off tracks. So we're leaving these marks all around us, but how do we differentiate them, and what are the signs that some of these tracks are coming from specific animals or other things that are leaving marks? There's a lot of variables that are going to skew our tracks. So I'm going to start off with giving us a little bit of a basic outline on what some perfect tracks look like. So this is, in an ideal world, we can kind of see what's going on. And I'm just going to break it up into a few different things to look for. Again, I can't cover every species, but start to think about what sort of shapes each foot is making, or each claw, or sometimes even vegetation. So I'm starting with vegetation because it's something that we don't often think about leaving tracks. You don't think of a tree walking through a forest necessarily, but the vegetation will be making marks in the sand, and it's important for us to differentiate that so that we get a clear idea of when it's not vegetation. Now, something that may be a bit more visible that you may have seen is right here. There hasn't been a small little creature running around in a figure eight around this grass over and over and over again. This is purely from the wind. So those really soft, delicate, light leaves and grass blades coming out of the ground there are actually strong enough with enough repeated motion to create these beautiful tracks around the vegetation, to the extent that it's really exposing that bare ground underneath that silty sand. And so we need to take into consideration these marks. We're going to see it obviously on grasses that are in the wind, but even a branch that isn't currently touching the ground, if it's windy enough and then starts to swoop down and make impressions on the ground, that can show a track even when it's currently not windy when we're there. So we need to think about what's touching the ground. Some tips for vegetation. We're looking for generally consistent markings. So if it's coming from the stem of a plant, it's going to have that beautiful radial arc, that nice sweeping motion. So we're going to check the base of plants. We're going to check trees, see if there's anything drooping. We may be able to even tell, which could be quite interesting for us, the wind direction. Sometimes if something's sweeping in a more lateral motion, then we could maybe infer the common wind direction, or at least the most recent wind direction. And we can consider recent weather. Was it very windy? And when did it last rain? And I'll talk about rain a little bit later as well, but rain is a very important and useful tool for us when we're looking at tracks. So ruling out vegetation, moving on to some smaller critters. Maybe when you've been tide pulling or rock pulling, you've seen some little marks like this in the shallow pools. We can see some nice little squiggly lines. We're going to see this from a whole host of different invertebrates, and they're generally going to be quite small in size and generally quite tight in movements, because if you're small, your turning circle is going to appear a lot smaller too as well. So we're even seeing the tracks all along the beach. Beach is a great place to get yourself started for tracks, sand bound, and we get some interesting things coming in our tide pools. Always worth having a little look there. But what about when we come onto land? We can see right through the center here some really interesting little scuff marks, and we'll zoom in a little bit further and it'll tell you who we've got. But we can see some beetle and insect tracks. So we've got a beetle on the right, and this in the center, I'm assuming is a larger beetle as well. It's quite tricky to tell which of the thousands of species we have here, unless I was to follow it and maybe monitor it. And also checking local field guides will help you. But for our insects, what we're going to be looking at is obviously our size. We're going to be looking for a much smaller array of tracks, which means they need to be quite clear. So tracks get smaller, relative to, say, grains of sand. That definition might get lost. So if we have a really perfect medium, we're going to see some really nice tracks. Think about the number of legs. Are there going to be many legs, or maybe even none, like some of our worms and smaller wriggling insects? And we need to think about movement and flight. So a beetle generally going to be moving in this straight line fashion. But if you're looking at something like a grasshopper, suddenly those tracks are going to disappear. So thinking about what your potential options are for the track, think about how that creature is moving. And that's really what we're seeing. We're seeing that leftover movement displayed in the sand or the mud. So generally size is going to be a really good indicator here, but some of those patterns, this sort of beetle pattern is quite common. You will see something that's quite low to the ground where the carapace or the body is dragging along. So looking at those drag marks as well, and lots of tiny little legs. You've probably seen this walking along a beach or a riverbank. Classic bird impressions here. But what about these? Also birds. So birds will have different shaped feet and claw arrangements, but we're generally going to have this quite obvious toe effect. It's quite a classic track, I think. If we think of any bird, we can conjure their footprints to mind. But then we start to think about how they're going to be presented. And there's a few different ways we can tell sort of the type of bird. Again, it depends on the species, depends where you are. But if we're looking for these really prominent kind of pronged prints, we're looking at our bird prints. In the snow, we might see our lovely ptarmigan, and we'll talk about snow, but we're still going to see, you can see the claw kind of extending out there, even a ptarmigan, which has lovely little snowshoes on to help disperse their weight. Their prints aren't going to be as defined, but we're still going to see that shape. We've got our two legs, so we're going to see that classic 1-2 pattern, but we do see birds that hop, so you might see those tracks paired together. We may also have our tracks disappear as they fly away. Generally, when a bird is taking off or landing, we're going to see a difference in their track as well. We're going to see a bit more of a scuff as they come in, depending on how they land, and a runoff as they're taking off. So we can use that to infer, did they take off and leave, or did something swoop down and grab them? So with birds, looking at their toes, we're going to be looking at the webbing. That's going to help us see if they are a wading bird. Generally, in a perfect world, we'll be able to see a bit of the outline of the webbing. You say if a duck is standing on a riverbed with some nice silty riverbanks, and you can see the outline of the webbing. That's going to tell you that you've got your waders there. So, you know, ducks, swans, goose, even gulls, if it's deep enough, you'll start to see that webbing. Most of the treads that you notice from like standard perching birds are going to have 3 at the front and then 1 at the back. That's really helpful for them to hold on to slender twigs when they're flying around in bushes and underscrub. And so you're generally going to have that really prominent, quite long compared to the size of the bird, toes that'll help them to grip. And then if we start looking at bigger birds, we're going to see maybe some of them are going to have their bulkier feet or wider spread. So doves and pigeons are generally going to be wider than our songbirds. And sometimes for our game birds, so things like our grouse, our pheasants, turkeys, and our ptarmigans, they can be a little bit harder to see that hind toe. Sometimes it's so small it doesn't even touch the ground. Along with our shorebirds and our waders, like this picture behind, we're not seeing that prominent hind toe. What we also sometimes see is something, if you see 2 forward and 2 back, this may be an owl or a woodpecker and some parrots as well. So having an idea of the arrangement of toes is going to be helpful, but we're looking generally for that 3 or 4 toe pattern. So that gives us a pretty good idea of birds. When we're looking more specifically, that's when we need to start looking into our species in particular areas, but just in general for birds. Now, this one might be a little tricky to see. I'm going to start training your eyes as we move away from our more perfect tracks. But if you have a look just where the dark green vegetation is through the center, you'll see a consistent line coming through. Now, this is a tail strike. And this tail strike, if you have a look here in the sand, is continual. We're not seeing the tail go up and down. So this implies a tail that's been dragged behind. You can sort of see it here again, kind of moving diagonally through the center of the image. It's quite faint. And then we can start to see, as we zoom in, some little scuff marks on either side. We look at this photo, much clearer, very high contrast image, thank you. You can see this strike that's continual through the center, a little bit of a wibble, and we're seeing these feet on either side. We can even make out a couple of claw impressions, those little tick marks in the feet there. And what we're looking at are our reptile tracks. So when we're looking for our general lizards, we're looking for this consistent tail drag. A lizard isn't really going to be lifting its tail up in general. There are some species who do, but across the board, generally, you're going to see this consistent tail strike. And our legs are going to be out to the side. If you've ever watched a lizard or a reptile move in that way, you know, that really sort of exaggerated side-to-side walk. And that's because their legs and their like hip and shoulder joints are going to be extended out to the sides. They're not underneath the body. So we're going to see those leg and claw marks to the sides. Or we're going to see no legs if we have a snake. Snakes will have that beautiful S, but sometimes they have more of just a pushed out ripple on either side. But we're going to see that drag throughout the sand. So if we're not looking at these examples, we're pretty happy that not vegetation, not insects, not birds, not reptiles, they're all a little bit more distinct. We can move on to mammals. Now, as fellow mammals ourselves, we like to differentiate more between the species of different mammals, and we have a familiarity with mammals. You may have a dog or a cat at home. You maybe know what their footprints look like when they come in after a rain and they're all muddy and tread through the house. So we get a bit more exposure to mammal tracks, just I think by being mammals, associating with mammals. They're big, they're furry, they're cool to look at. So I'm going to look at some mammal tracks. I'm going to show you some tips on differentiating specific mammals. And then we're going to start talking about reading tracks in a more general sense. But we're starting to get our eye in and get an idea for them. The other great resource, and I have the Australian version, is a tracking book. So if you're on your mobile, you can swipe across to my face, and I'm showing up a book that's called Tracks, Scats, and Other Traces. This starts to get really, really in detail for specific animals in your area. So a field guide like this, when you want to really up your track game, is going to be really interesting. They'll show you some specific birds. They'll show you some beautiful impressions of the feet and how they walk. And they even go on to things like scat, which is also a very, very useful tool. I love a good field guide because they always have a ruler printed on the back so you can measure your tracks, and we'll talk about scale in a moment. But once we start to look into the specific species, we can get a lot more information as well. So a handy field guide, would recommend. So let's have a look at some mammals in a perfect world with some nice tracks, and then I'm slowly going to get less perfect. We're going to talk about how tracks are skewed. Here we have some lovely paw prints. Now, paw prints are something that I think are quite common to come up. If you look at any hiking forum, I'm sure you'll see someone post some paw prints and ask for them to be identified. So some things that we can look for our general pawed creatures, we're looking the common culprits, I guess. We want to know whether it's a dog or a cat or a fox. Talk about bears in a moment. But these are the common ones that I think get a bit muddied together if we don't know which one we're looking at. If we look at the bottom black image, we can see that there's two prints with claws and one underneath without claws. This is going to be a really helpful indicator for cats. So cat is the bottom print, and actually the print that we have in the sand here. And cats don't put their claws down when they walk. They retract their claws as they walk, which means we're not going to see those claw marks. So as soon as you see claw marks, we're thinking not cat. we're going to be looking at a dog or a fox in these examples. We can also see with the cat, the toes are more sort of in a line as opposed to 2 up the top and 2 on the side. And if you have a look at the pad, if you get a really clear view of the pad, we're going to see 2 lobes at the top of the palm and 3 at the bottom. And that's very typical for a cat. So we're looking for those sort of arrangements. Nice top, even toes, no claws, and that defined pad at the bottom. When we move on to our dogs and our foxes, we get claws for both. In the top image, number 1 is a dog and number 2 is a fox. So when they are of similar size, it can be quite tricky. But we're looking at generally the fox, those first 2 or those front 2 toes will be delineated. They'll be completely separated from the back 2 toes. So we'll see that separation, whereas a dog will be a little bit more together. When I see a dog print in practice, I find the gaps in between around the palm and the side 2 toes, it looks kind of like an X. And I find that X or that more kind of diamond shape is quite prominent when I'm looking at dog tracks. I think I have some dogs. Oh, this one before is a bit more X'd, but it's quite soft sand. So that's going to help us with our dogs. And then our little front 2 toe beans are going to be separated for our fox. So that'll give you a little clue. Size is going to be really helpful as well. Generally, if we're looking at a large wolf, that will help. And think about the context. As we start moving into our mammals, we want to think about who actually lives there, who could be leaving these prints. That's going to help you a lot because you're going to narrow that range down. Now I'm going to be tricky for you, and I'm going to jump across hemispheres at various times. So you got to think on your feet, so to say, to figure out where we are. But I'll clue you in. So that should give you a little bit of a tip. I think claws are a really big one for cats. In Australia, we do have feral cats. That's what this is. And so our feral cats can get quite large as well. So they can easily have footprints as big, sometimes even bigger than a fox. So something to bear in mind if you're having a look in Australia. Now bears, we often think of bears as tracks that we want to know where they are so we can go the other way. Luckily in Churchill, we are nice and safe in our big polar rovers. So these are some polar bear tracks, and we're going to see 5 toes for our bears, which is going to be very helpful, and we will also see claws. Polar bears can lift their claws if they want to be really quiet on the ice, but generally when they're walking through the snow, we are going to see some claw impressions as well. And they're going to be quite distinct because they are huge. So 5 toes, very much going to help us with a bear. Now, what about this? This also has 5 toes and has little claws. This is when we start to look at many different species of mammal. Now, this is in Australia. You can see a gum leaf in the side there. That's going to help tell you where it is. But this is from our brush-tailed possum. So our possums are marsupials like your opossums. I think they're a little bit cuter, but I'm biased. And you're going to see quite distinct little toe prints. So these are some things when you move into a new area, sometimes it might be worth having a little search and seeing what potentially some of those species you hope to see, what their tracks look like. And then you'll be able to get a little bit of an idea. I just think possum tracks are some of the cutest tracks because they're like a kid leaving a handprint. So that's a few different mammals. We'll start to move on to some other signs and what that means. So this one's a little bit trickier, and I'm going to try and pull your focus away from an individual print to the context that we're in. Now, this is Northern Hemisphere. This is North America. We can see a lot of different action going on in the mud. I'm sure some of you have already guessed. It can be hard to find a distinct single print in something like this that's been used so much. But if we look up and we look across, we can see these beautiful channels coming into the mud. And if we look a little bit further away, we see some chewing. So that's going to tell us that we've got our beavers. And we can use that, maybe we then see a really clear track, and we can use that to come together to start to identify and sharpen our tracking skills. So what about this? This is also in the mud against a riverbank. We've got some beautiful claws, but note the gum leaf here. We are back down in Australia. So we have 5 claw marks. So we're not looking at a dog or a cat or a fox. And we're going to think about some of our Australian animals. I was flicking through trying to find all the photos for this webinar. And I was like, oh, what is this, like a little bear track that I saw? And then I forgot that this was in Australia. So I went to our little local bears, and this was actually this specific wombat who I crouched down in the grass and waited, and it ended up walking right up towards me, which was pretty cool. And this is a wombat burrow here as well. And this is a cuter photo of a wombat. So we do see our wombats, and they'll have our beautiful claw marks. So again, context is important. This track you may have seen. You can see it potentially in your backyard, as well as out in snowy environments. There's quite a few different species that move like this. And we're looking at the arrangement of movement and the arrangement of legs. These tracks were in New Zealand, and I was walking into a snowfield here. And my traveling partners saw these tracks and pointed to them with a big question mark in the snow. And so for the people behind me, I then wrote what it was in the snow. And this is a rabbit or a hare. In this area, it would have been a little rabbit. And we can see that with the arrangement. So when we're looking at any rabbit or hare-like creature, we're looking for this arrangement of this 1-2 staggered. That's the 1-2 of the front feet. And then the back legs are going to hop together. So we're going to get 1-2, and then we're going to get 2 that are in line with each other, and that's the back legs coming forward as it bounds. So this pattern is really indicative of any rabbit or hare. So even if the tracks are really muddied, you can't make out the individual foot. This pattern will always tell you that it's something that's bounding in that motion. When we think of mammals and going down to the beach, we also have to start thinking about some of our other mammals. And so we'll talk about some of our seals and pinnipeds with just one example. But thinking about how the animals are moving, just like our rabbit, thinking about how those feet land, what do you think these tracks are going to look like as we see mum and pup coming out of the sea? We've got these flippers coming forward, we've got this body dragging, and so we're going to look at those patterns. Now I'm going to introduce you a bit more specifically to one species of mammal, because I will be using these guys a little bit because these are the tracks I often see around my place. These are our kangaroo tracks. So if you have a look, we can see there's quite a lot going on here. We've got what looks like these little strikes through the center. We've got some prominent deep gouges, and then we've got these little handprints. And this, in a perfect world, is some of the kangaroo tracks that we'll see. This is in really, really nice, soft, muddy sand, actually straight after a rain. And we can see perfect definition of those little hands. And we can even make out the details in the pads of the hind feet. And just to the left of the left handprint in the center, we can see a little tail impression. And so this tail is also acting as a track, and it's acting as a limb in this case. So our kangaroos and our wallabies, our macropods, macro, big, pod feet, they've got big back feet, they will tell us quite a lot by the way that they move, and they use this 5-limb motion when they're walking. And so we call this 5-footed motion pentapedal motion. Pent, 5, pedal, foot, walking. So we've got our 5-footed motion. Now I'm going to show you a swamp wallaby walking, like a frame by frame. And so you can get an idea of how these tracks are landing on the ground. So have a look here. We've got those beautiful hind feet. We've got that heel planted firmly on the ground and that tail sweeping out behind. And as this swamp wallaby reaches forward, it's going to take its first step. Now here, have a look at where the back feet are lifting off. They're pushing all that weight into that toe area, and that's where we're going to see the deepest impression from our kangaroos and wallabies. And you can see now reaching out with those claws, putting them down on the ground. So that's where the first impression is going to be those front paws with their beautiful little childlike handprints. And as that back feet lift off, have a look at where the tail lands in relation to where the back feet are. So we're going to lean forward, put all that weight in, and that tail is lifting and it's being put exactly where those back feet are. So when we look at that track, we're getting a tail right through that previous track. And that's why we see it in the same area, because that tail goes in the same spot. Now, as those big back legs get lifted up, they get fully lifted off the ground. So you can see this swamp wallaby full weight in the front and on that tail. These are the 5 limbs, 1, 2, 3, 4, 5, when we include that tail. And it really is used as a limb when they're walking. And then those back legs will continue to come forward and they're going to be planted right on either side of those front paws. Great. So that's going to tell us we're going to get 1, 2, 3, 4 right there in a row. We can see it in a single frame. And then we know that tail is going to come through if it continues to walk. So now it makes more sense when we see that kangaroo or wallaby come through. We get that 1, 2, 3, 4, 5. So we're going to keep that in mind because I'm going to come back to kangaroos. We're going to talk about, now that we've had a thought about these perfect tracks in this beautiful media, what does it look like in each type of ground cover and how do they differ? Because this is something that we need to bear in mind when we're looking at tracks so that we can more accurately interpret it. When we start looking at not just species, we're looking at the arrangement. Sometimes size can be really important if we want to differentiate, say, between, a polar bear and a black bear. Without any other information, one's going to be bigger than the other. So if we can read the size accurately, it's going to be helpful. So sand, I think, is the most common thing that we think of. We've all been down at the beach and seen all the footprints in the beach. This beach, we can walk on just a little bit, but not that far, because this is mainly the beach for the Australian sea lion down in Kangaroo Island. And you can see, if you look at the base of this image, the tracks here look very undulating like waves. This is a lot of human and seal action. But if you look a little bit further on where we can't really walk, you can see these more defined lines of tracks. And that's where we're going to see our seals and sea lions moving in that motion. And so we can see the direction of our beautiful sea lions here. So sand's going to be really helpful. We can see in this photo, obviously we're not looking down at the tracks, but I just wanted to point out in this photo, if you have a look behind the sea lion here, you can see really rough, coarse sand, and in front you can see remnants of old tracks. It was quite a windy day this day, and so a lot of those tracks do get smoothed out or muddied. They become less clear as they get weathered, often with wind, also with rain, and so over time those tracks are going to be less distinct. So for sand, we're looking for like a crispiness. We're looking for really sharp textures that are different from a general muddiness that we see with age. So if we look at back in the desert here, there are some small tracks here. There's a tiny beetle running through, but we've got some little divots. They're from a mulgara. I don't expect anyone to know what a mulgara is. If anyone does, please write a little comment because no one knows about them. They're basically a small little hopping marsupial in the Australian outback, but they leave these little bean impressions. But it's really hard to see. These are old tracks. It's been weathered. It's really not distinct. And so it's only because I know that I was looking for these guys and was actively tracking them that I knew who it was. And so we need to think about that crispiness of the sand to get the best impression. So back to our sea lions, there's 2 paths coming down, and can you make out which path the sea lion came down? Now we're looking for a more distinct, kind of more textured. Think about, a really crisp, high contrast image. And we're seeing a bit more of that scuffing happening on the right path. Helps that the sea lion sitting right below where they've come down. But you can see that slide through the center is very smooth. There's nothing else interrupting that. Nothing has blown. And the edges where those flippers have come have scuffed on the side. Whereas if we look on the left path, it's generally, there's just not really a clear indication of what's going on. I don't see a track through the center. I don't see defined imprints from those 4 flippers. So we can start to see where an animal may have come from. The thing to consider with sand as well is what kind of sand it is and how soft it is. So this is a kangaroo when it's hopping. When they're hopping, they don't put their front paws down, they just use their back toes. And this one had a soft landing. So if I was to use my field guide and to compare the size, which is in here, of every single type of macropod that we have, we can see a scale that's given that gives us a scale of the size of the foot, and that can help us get down to species level. So we can get really, really accurate with tracks when we have a comparison guide like this one. But the trick with this is in sand, it's going to exaggerate that size. So this is going to look a lot bigger. I'm going to think it's a big red kangaroo instead of a small gray kangaroo, just because of how soft the sand is. So with sand, we want to think about how sharp or crispy it is on the edges. That's going to tell us the new tracks. And we want to think about exaggeration. But otherwise, sand is really, really useful. Okay, my favorite medium for tracks is probably mud. This was out in field work in Alberta in the boreal forest, and it was a muddy day. We may think of mud of getting stuck. This was not me. This was my field partner, for the record. I have never been bogged. I say that, and next time I go out, I'm going to get bogged because I said that. Mud is really good for tracks, not just for driving through and getting really deep wheel impressions, but also for the way that it kind of sticks together in that clay fashion. You get amazing detail for good mud. This is the toe pad of a kangaroo, and you can make out the individual bumps on the skin of that kangaroo because of this mud. Like, it's just so distinct. And because it was so distinct, I could tell you that this is a red kangaroo. I can tell you the species because I can look at the pad with my field guide and I can identify it really accurately. So I love mud. The thing to think about, again, we want nice, crispy, high definition tracks, but it also means that they won't necessarily get washed away as quickly by the wind. We do need decent rainfall. Even a light rainfall might not remove a track fully. So this is a cat track here. Note that there's no claws, and we're seeing that nice rounded display of toes. And this is quite an old track. We can see little bits of dust have gathered into the track, but it hasn't rained here in a really long time. So we need to think about the age of that track. So yes, I could be like, oh my God, there's a cat nearby, but that could have been a week ago. And sometimes for dry mud, that could have been a month ago. It can really preserve it for a long time. If we think about fossilized tracks, it's often in this sort of sediment where we see the tracks that have been left for so long, everything's come on top of it, and now we have tracks from dinosaurs. So be careful when we're aging tracks in mud, dried mud especially. We also have snow. Snow is great. Unlike sand or mud, we don't have to wait for a patch of bare ground or just be at the beach or in the desert. Snow will cover everything in an environment, and it means that there are tracks everywhere. If we follow these little footsteps, we can see a little Arctic fox tucked in the very center of the image. So snow is going to be really, really helpful. It can be tricky to photograph. So this is a very blurry photo of a, looks like a fox on the left, just from the arrangement of the 1-2 in the background. I'm not seeing the hind legs come through of a rabbit, which I thought it was a rabbit originally. And then on the right, we've got a polar bear. We're seeing that sweeping mark. So with snow with depth, we're going to see these streaks. As you come down into deep snow, your foot's going to catch, and so you're going to see these big, long streaks. So that's going to exaggerate the size of our tracks, and it's going to lose definition. So while there's tracks everywhere, you have to think about the condition of the snow. And the other thing to think about is how to even capture the prints. It can be quite hard to take photos of a track. Here are 2 photos taken minutes apart, one with a flash and one with not. And these are wolf tracks in Churchill. And it can be very hard to see that definition from a photo after. You kind of want to get that raking light coming across the side and try and get as many different types of photos as you can. The other thing that we see in cold environments is not just snow, but also ice. And this is a really cool effect that we sometimes get over ice, where the tracks create a surface on the ice. From the heat, you get that nice warm track. It's actually going to pick up the spin drift that blows along, and it's going to stick it on top of our track, like dusting glitter on some glue, so to speak. And so we actually get these inverse tracks. So the tracks, rather than pushing down, actually stick up. And it's a really beautiful effect. So these are some polar bear tracks across the ice. So snow and ice, great. It's everywhere. We can get a really cool indication of everything that's out there. You can't really walk through the snow and not leave tracks. But we want to think about the depth. We want to think about the melt. As it melts, it's going to widen a track. And so that's going to change the size. So exaggeration is big, and that's streaking as well as another type of exaggeration. The last little medium I want to talk about is vegetation. Generally, we think, oh gosh, if there's vegetation, I'm not going to see any tracks. You will find areas of dirt in between your vegetation. Look there. But you can also see some of the way that the grass is pushed down, and that can help you to see where little trails are. So just behind these prairie dogs here, there are a few trails actually extending in a V and then joining in sort of a triangle shape above the prairie dog. If you can spot that, good on you. It's not the best photo, but we can see that, and that will give us an indication of trails that will hopefully lead us to other traces. So even if we just get a really faint impression, it might lead us to something else. Now I'm going to throw you down under. This is back in Australia, and we can see this silvery impression where the grass has been pushed down. Here it looks kind of blue-green on the grasses here in Tasmania. And by following this little trail, we can get to a wombat burrow. We can actually see some wombat droppings here, which are nice and cube-shaped, which tells us that it's a wombat. But by following that pushed over grass, we see that silvery effect. We're going to see grass look silver when it's pushed away from us, and it's going to look darker when it's pushed towards us. So have a look if you've ever driven even just like your lawnmower across the lawn or a car through a field. You'll see that in the tire tracks. Look both ways, and you can see the difference in the color of the grass as it's pushed down. And sometimes it's really obvious, like when 40 cattle move along a fence line. And they can really turn up the grass. So this is a very obvious trail in vegetation. We start to get down to the mud layer here as well. So it can be really subtle in vegetation. It can be tricky. Have a look for those silver cues to help you see where things are going. But then really you want to start finding other traces. So I am going to quickly talk about some of the language of tracks. We're going to see what can we learn from all this information. We can learn about the number of individuals. These are birds. We've got these nice 3 toes at the front. These are very big birds. These are our emus. And the emus here is quite easy to tell if there's one emu or multiple emus based on the number of tracks. But we can also see not just the number of individuals, we can also get an idea of the age. So here we can see on the left, these tracks are quite old, at least since a previous rain. We're seeing this speckling on the ground that showed that there was some sort of rain that fell, and it softened these emu tracks. If we look here, this is my footprint, and these are 3 days apart in the same area, and we can see what that rain has done to my previous foot and then my foot straight away. You can see how crisp and defined it is, or it becomes this really soft impression. So we can see the age of tracks by understanding the weather, and I'll talk about some other aging techniques that we use in research, because if we know when the ground changed, we know when the track was laid. So if it has just snowed, we know that the track had to be laid after that. But we can also artificially change that. We can create our own flat surface and say at 9 p.m. I flatten this surface. That means anything after that had to be here since 9 p.m. And I'll talk about that in a moment. We also have our speed and our direction. So back to our beautiful little kangaroo here. When a kangaroo is walking, as we saw, they're going to put those front paws down, but when they're running or they're hopping, we're just going to see their hind toes as they bounce along. So kangaroos are really easy to tell speed because their tracks look completely different. But if we think about you walking versus you running, the spacing between the tracks is going to tell you how fast that animal was moving. So now you know who it was, how many individuals there were, when that track was laid, and now you know how fast they were moving. So if we have a little look at this picture, it can be a bit hard to see up the back, but you're seeing the front paw impressions, and then suddenly as it turns that corner along the road, that disappears and it starts to go into just the two back toes. So there was a kangaroo that was walking, changed direction, and is now hopping off. Now we have an idea of that whole animal. We can start to visualize what they were doing there. And if we continue down this line with kangaroos, we sometimes come across things like this. And this is a bit of a party going on. You can see a whole lot of scuff marks. And so we can start to think about what the behavior was here. So here we had a bit of a kangaroo party. This is likely to be some males sparring or having a tussle. It could have been a little bit of feeding behavior where we see some digging, but generally we're going to see these sort of areas. There's multiple individuals. They were here for an extended period of time because they left multiple tracks and they were moving back and forth and all around and churning up the road. So now we have a bit of an idea of the behavior. So have a think about how those tracks have been disturbed and what behaviors we're going to see from that. We think about a fox who's foraging. We actually see this fox is looking at tracks that have been churned up from a car on the side of the road and hoping to find something in that embankment. So flipping and looking in piles of snow or edges of roads is going to be useful. Or maybe they were just playing. This is a little polar bear cub just tipping over some ice. So you'd be following these tracks, footprint, footprint, and then there's this whole hunk. So were they looking for something or were they just having a play? We're learning the behavior by the marks that are left. And we also see animals use others' tracks. So this is a snow bunting and it's actually foraging in the tracks that have been churned up by our polar rovers on the road. So as it's been churning through that mud, this snow bunting is like, yes, perfect. There's this layer of vegetation that I couldn't get to before. And so things will interact with our tracks. Sometimes when we're looking for tracks, we're looking at those other traces, and this wolf, I'm afraid I caught it early in the morning just as it woke up and it was doing its morning routine and left some other droppings for us. And droppings are so great for tracking as well. If we follow our tracks and you don't know what species it is yet, your scat is going to help a whole lot. And I won't go into all the scat because I could do a whole another hour on scat. But things like our field guide, they have scat as well as tracks. So scat is really, really useful. I'll leave that wolf to its privacy. And then we also see other things like diggings. So this is an echidna down in Australia, and you can see that beautiful digging hole there. Echidnas can move about a ton of earth in a year, a single echidna. So looking for things like diggings when you couldn't normally see tracks is really helpful. And now we can start to broaden it and we can think about what other marks are animals leaving around. We can see these beautiful boring tracks in a tree. So how do we use all this information? We can find out the behavior, we can find out the speed, the direction, and we can start to find out the time. So I was talking about how we can artificially create a blank canvas. And we use this in research, and I've done a number of studies using tracks. We can make sand plots for surveying. This is a really, really useful tool. This is us learning. This was back in my undergrad days. And we raked these sand blocks here on the road. And it means that we know that yesterday afternoon we raked this, there was nothing there. Everything that has passed through here has been here in the last day. We can look at this beautiful tail strike that we're all pointing at. And you can see that we have a ruler here as well, and the same field guide to identify the species. So we can measure those footprints and we can find out the species. So we've got behavior, we've got time data, and we can use that to get an indication over a large area to see who's been there. Sand plots are really useful, but we need an area that's sandy for a large sand plot. It's great because we get this extended behavioral data, but it can be hard to find exactly where we're going to put a full sand plot. So the thing that we do that's a little bit more efficient is actually just driving. And so we can drive along a track. This is out in the, I don't know which side I'm on, I think the Strzelecki Desert. On the other side is the Sturt Desert. And this is along the dingo fence, which I've mentioned before if you've seen any of my other webinars. But we can just drive along the track, and it means that I can lay about, 30 kilometers, say, of tire tracks in the afternoon, and I can come back in the morning and I can check those tire tracks and I can say, only the things that have crossed my wheel marks were here overnight. All the stuff on the other side, I can't tell how old it is because it's mud, it might last a long time, or it hasn't rained, I can't tell. But anything on my tire tracks, I know was here. So I can now do a survey across 30 kilometers and I can tell you all the species that have been along. So you'll drive along very slowly, get out every time you see a track, and you'll survey that and you'll write that down. So we get a really good indication of presence. A cool thing here, we can see some tracks going off camera up the top of the screen along the tracks, and they are a bit exaggerated. I don't know if they're a cat or a fox. Usually it's cats out this way. And then we can see 2 kangaroo strikes going the other direction. This is something that we've noticed from tracking, but we can use ourselves. Generally, predators are going to patrol along the road. It's easier to cover larger distance and they can see better. They don't have to try and navigate any terrain. So foxes, cats, dogs, wolves are going to be walking along the road. And then our prey species are generally going to be crossing the road. They want to get out of there as quick as possible. So we often see them going the other way. So we can use that information on how we make our plots, as well as learning the behavior of who's going to be there. We also see a difference over time. If we look at all these studies, we see that generally we're going to see predator species that are hunting at night are going to be more active when it's brighter. So when we have a full moon. And then when it's cloudy or there's a no moon, then we're going to see more prey species out and about. So we get to learn quite a lot about how these animals act without even seeing them. And that's the really cool thing about tracks is we don't actually need to have the animal right there. We can stay safe, but we're also not impacting that animal. So when we come to these beautiful polar bears, what about this guy? What are these tracks that this bear is laying down that we can learn? We've already learned all of this behavior. We can learn time, we can learn direction. But what if we want to know more? If we want to know about the diet or the individual condition? We'd have to survey the animal, right? Well, no, not anymore. We can actually get more information from tracks and we don't have to disturb the animal at all. So there's a really amazing non-invasive way that we can get information from tracks. Works really well in snow. We don't want to encourage interactions with bears, and we want to be able to get more information that anyone can gather. And so we've actually been able to get what we call environmental DNA from tracks. So here you can see a researcher. This is from Michaela and Elizabeth's paper. This is the Mixed Research Center in Sweden, as well as the World Wildlife Fund, the US Department, the Arctic team. I was fortunate enough to travel with Elizabeth Kruger, and she told me all about it, which was really amazing. But we can actually, from those footprints, gather DNA. So you can see here, scooping up the snow and there's just enough trace DNA that we can now actually get that we can find out individual information about that polar bear. And so the retrieval rate was really, really good in snow. Obviously, you're already doing a bit of a selection. You're choosing perfect tracks that are in good fresh snow. But in this study, they were able to get about 87% of the polar bear snow tracks that they collected. They were able to get good DNA to be able to identify the species, which means you can start to tell about the population health in general, and we can track individual bears in a way that we couldn't before. They also did this for lynx, and they did it for snow leopards as well. And they were also able to get about 60 to 70% success in general, which means about 6 to 7 out of every 10 sets that they collected, they could analyze. It's really, really cool stuff, and it means that someone who's not trained to deal with bears in a research capacity can go out, just scoop up some prints and give us that information. So there's some really cool stuff happening with tracks. We learn a lot of information about our species, and it's something that I think you should keep an eye out when you're next there. So I hope you've started to think about your tracks, and I hope that next time you're out, you can do your own survey. Next time you're walking along a beach, maybe you'll see some kangaroo tracks or something a little local to your area. Take photos if you want. You can rake a plot in your backyard. If you have a little dirt patch, maybe you want to smooth that out and see if anything walks through it over a day or a week. And just keep checking it, keep practicing, keep looking at those tracks. When you take photos, try and take photos either low to the ground or with a raking light. So sometimes you could use the light on your phone to create a light that skims across the side and you get a better track. And if you can, you want to put something in for reference. So here's my hand or my lunch when I was out in the field. It gives you a size comparison for the tracks. So next time you make a snow angel, remember what you're leaving behind, remember what information you're leaving behind, but also you're creating your own plot. It helps that I wrote 2022 here, but I can also see a fox has walked through in the past day and has gone and looked at the bin and then walked away. So we're learning our behavior and we're learning all of that from tracks. So thanks, guys. I hope that was interesting for you. And if you have any questions, please drop them down. And keep your eye on the ground.
All right. Thank you so much, Nikki. Before we start in with the questions, I would like to remind everyone that you can submit your questions via the question field in your control panel. All right, let's get to some questions. So, how did you get started in tracking?
I think in general, I mean, it's probably the same reason I got started in science and guiding is just that curiosity, just wanting to understand what's around me. And I'm hoping with this series that we're starting to foster that a little bit and just being curious about what you see around you. We're quite fortunate in Australia. I grew up near the beach, and where we don't have beach, we have a lot of sandy soils. So I've just been surrounded by tracks for a long time. And then it's just starting to wonder what's happening. I think kangaroo tracks are just really rewarding because you get that difference between walking and hopping, which I find really fun. And then it just became practice. I started keeping a closer eye out and trying to think about who was moving where. And really, like, the field guide gave me a huge step up. As soon as I got a field guide local to my area, like, yeah, it just changes the way that you see everything because now you're not just guessing, you have a better idea of what's happening. And so just expanding your knowledge base a little bit and then practicing curiosity.
Great. Thank you, Nikki. So, you showed a picture of a fresh footprint, and it seemed to be even upraised rather than indented. Can you
Yep.
talk about that?
It actually isn't. That is a bit of a trick of the light. It's a fair ways back. I could flick back to it, but if you have a look at the recording, it takes a while. You kind of have to stare at the image for a while. And I've shown this to a few people, and they've all said the same thing. Just because of the way that the light's coming, it looks like the dark shadow is on the far side and it's raising the footprint, but it is actually inset. So it isn't raised in that scenario, it just looks like it. That's just a cool optical illusion that I happen to capture. We only really see the inverse prints that are sticking up when we get that sticking on top of ice. I can't really think of any other time that we would get it raised up, unless something, then we're talking crazy time scale. There's a track, sediment falls in, and it gets cemented in there, and it becomes like fossilized, and then everything else peels away around it. Then you could get like a raised track, but otherwise, that one's just stepped in. But good pickup.
Thank you. So it's pretty amazing that you can get DNA from tracks. How long is it possible to get DNA from tracks? Uh, how long does it stay around?
Mm, yeah, I don't have exact figures on that, and I think it would come down to a number of factors. It is a while that DNA is left there. It's just how long that DNA gets exposed to certain things like UV, wind, getting buried, getting disturbed. We want a fresh track that has a larger concentration, because the only reason we can get this environmental DNA or eDNA, if you look up eDNA, you'll start to see a lot of this. We're getting really small trace amounts, but we do need a a relatively decent amount of tiny little bits of DNA to be able to get a sample. But it can last for quite a long time. And we actually use eDNA quite a lot in river systems, which I just think is really cool. So we can get trace DNA elements from species that are moving and swimming and feeding and shedding through rivers. And so we can see those flow on effects through rivers as well. I don't have an exact age because I think it would depend, but it's longer than you think in a way that you're like, oh God, there's DNA everywhere, but you got to know what you're looking for. Yeah.
So, besides those times where you specifically are setting out to find out where animals are coming from, if you
Mhm.
just run across a track, how do you determine how long it's been there if there's no other
Mm,
indicators?
yeah, I think start to just bring all the information you have together. So if you just stumble upon a track, have a look firstly as well what other tracks are there and kind of compare them, even to your own footprint. You've always got a comparison of what a very fresh track looks like in the thing that you're standing in. Because as we saw, it's different in sand and mud and snow, but you can make your own track right there and you can be like, whoa, my footprint looks way crispier, way sharper than this. So I can assume there was some sort of aging, either through wind or rain. Then I would start thinking about weather. I think weather is one of the quickest things that will change a track. Is it currently windy? Are you already losing your footprints from 4 steps ago? Then the track that you're seeing is probably quite fresh, because otherwise it wouldn't be there at all. But if you see heaps of tracks around, if you think about it on a beach, we're going to see impressions from people who were there weeks ago. So just think about the context that you're in. I would take a photo with some scale, and then you can go home and you can check the weather in that area. When did it last rain? And then you know at least it was since then, because usually that rain is going to be quite consistent at washing tracks away. So just pulling all that information together, just being curious, spend some time with it, and yeah, have a bit of a play, and it'll start to get quicker and quicker.
Great. We appreciate the advice. So, are there species of four-footed animals that can consistently put their hind foot in the same place as their front foot to maybe disguise that they are four-footed?
Yeah, we see this often with cats. We see quite an overlap with their tracks. When they're walking, they're often in line, and so sometimes it just looks like two really far away feet. So that's something to keep an eye out. Generally, if you have a bit of distance, try and follow that track. You should see a little bit of a difference at one point where things don't line up together. And then check some of the mammal species in your area, because it does depend obviously on the species. Cats are just really good at doing that sort of tightrope, slender walking. But we do see a lot of mammals generally are going to be broader set, where we're going to see different tracks. But yeah, that's the common example.
Is that considered a defense mechanism?
It could be a stealth thing. I think also just in general, if you're going to have a smaller profile, I think regardless of the tracks that you're leaving, if you're just leaner, that's going to be good. I think there's something as well with long legs, like moose tracks generally as well will come pretty close. And if I think of a moose walking, it's just a lot of leg. And so it's easier to bring those feet in a straighter line. I don't have to navigate as much difficult terrain if my profile is quite small. So there could be a number of reasons. I'm not sure how selective that is as a defense, because I don't know, I guess they're running from us, but generally other tracks, tracks will leave scent as well. So I don't know, I like it. I want to look into that if there's a driver there for single line tracks.
Great. Thank you so much, Nikki. I appreciate that. Unfortunately, that will be the last question that we do have time for today. So I'd like to hand it back to you for some closing comments.
Thanks, Rob. Thank you, everyone, for tuning in. I hope you found that interesting, and I hope you go out and practice. And I hope you're enjoying this series. Feel free to leave any comments as well. I'll be back next week talking about lichen. And yeah, stay curious.
Nikki, thank you so much for taking the time to present for us today. And I'd also like to thank everyone who tuned in today. If you're interested in information on how you can travel with NatHab, please give us a call at the number on your screen, or you can send us an email at info@nathab.com. Our adventure specialists are happy to help you out. Now join us tomorrow for our next daily dose of nature. You can check out this week's lineup, including our registration links, on our website at nathab.com/webinars. We did record today's presentation, and we will have the replay available on our website soon. With that, I will conclude today's presentation. Thanks for joining us, everybody. We'll see you next time.